Chapter 8 is all about these things called matrices and determinants. Well, we probably should figure out what in the world those words mean. So, first section focusing on matrices. So, in this section, we're going to study the streamline technique of what we did last semester. Not semester, goodness gracious, last unit for solving systems of linear equations. This technique involves using a matrix, which the plural of that is matrices. So, if you have m and n being positive integers, then an m by n, which is read m by n, it's hard to read that one out loud without saying the same thing twice. Matrix is a rectangular array, and it looks something like this. So it's going to be, leave a little space above it, but we're going to have a square bracket over here, and then it's going to be a closed off square bracket over here. We're going to talk about the rows and columns. So for our rows, the very top row is going to be row 1. Waiting for AirServer to catch up a second. And then the top, or the first column, is going to be column 1. Let me see if I can do something. Speed this up a second. There we go. It caught up eventually. So we have row 1 and column 1. Now, to help us identify that what we find in row 1 and column 1, we're going to call that A11. That means the term in row 1, column 1. Now we're also going to have row 2. And you're also going to have column 2. Now, row 1 and column 1, or sorry, row 1 and column 2 are also going to intersect, and we're going to call that term A12. So the first number is the row number, the second number is the column number, and sorry, I'm still waiting for AirServer to catch up. And then for row 2, column 1, it's going to be A21. And then for row 2, column 2, it's going to be A22. Now, we're also going to be able to go over to, we're just going to keep going. It's going to go on for quite some time. The last column we're going to use is column N. And same thing for the rows. The bottom row we're going to use is row M. So it's going to be an M by N matrix where M is our number of rows and N is our number of columns. So this term right here would be A sub M1, so row M, column 1. Then we'll have, sorry, waiting for AirServer to catch up there too, A sub M2. There we go. And it's going to keep on going, and we're finally going to have A sub Mn. Kind of like up top here, this would be A sub 1n, and over here in the second row it would be A sub 2n. So the first number in the subscript is going to indicate which column, or sorry, which row we're in. The second number is going to be which column. So each entry A sub ij is the number, or is a matrix, or of the matrix is a number. And an m by n matrix has m rows and n columns. I kind of already touched on that. And matrices are usually denoted by capital letters. So let's call this one matrix A. Now a matrix of m rows and n columns is said to be of order m by n. So looking at these 4 examples right here, A, B, C, and D, this first one has 1 row and 1 column. So we're going to say it's a 1 by 1. The second one has 1 row and 4 columns. So we're going to say it's a 1 by 4. Take a few moments to see if you can identify those other ones. So pause the video. And we're back. So this next one's got 2 rows and 2 columns. The third, or the last one, has 3 rows and 2 columns. So this is just kind of the setup of a matrix, just kind of what the format means. Now we're going to apply it to things that we looked at last unit with systems of equations. So here's a system of equations, and we're going to translate this into a matrix. So the system of equations, you're only going to be using the coefficients of your matrix. So I might actually add something in here. Looking at these 3 equations, the first one is x minus 4y plus 3z equals 5. The next one is negative x plus 3y minus z equals negative 3. And the last one is 2x and then no y term minus 4z. I really wish that minus was over here a little bit more. I'm just going to kind of go through and highlight each variable. So we've got the x's, we've got the y's. I'm going to highlight that the fact that there's no y there. And then finally our z's, I'm going to do in yellow here. So in an augmented matrix, we're just going to focus on the coefficients of our matrix. So I'm going to start on the left side with the x coefficients. So starting at the top row, we have 1x, so our coefficient is 1. In the second row, we have a -1 for our coefficient on x. In our third row, we have 2 as our coefficient. So again, just to kind of highlight where those are coming from, those are the x coefficients. Now in the next column, we're going to do the y coefficients. So the first one we had is -4. The second one, +3. The third one doesn't have a y term, so it's like there's 0 y there. And again, to highlight and color code this is coming from our y terms. Next up, we're going to do our z coefficients. So we're going to do 3 from our first row. The second one's -z, so that's going to be -1. The third row is -4z, so we're going to have a -4. And again, those are the coefficients that we got from the yellow from the z. Now, in an augmented matrix, what we're going to do is we're actually going to do a line there, kind of separating it out. Oops, sorry, I should scratch that. We're going to do a dashed line. Sorry, I got a little ahead of myself. We're going to do a dashed line there, and on the other side, we're just going to put those constants, what they're equal to. So we got 5 in that first row, -3 in the second row, and 6 in the third row. Let's see if I have another color that'll work out well for there. So those, again, are the constants that were on their own on that left side. Sorry, the right side. Goodness gracious. Now, the coefficient matrix is the same thing, just without the augmented part, just without the constants. So the first row would be -1, -4, 3. Next row would be -1, 3, -1. And the final row would be 2, 0, -4. So just the coefficients, ignoring our constants.